In the world of science, collaboration and sharing are key to discovery and innovation. Today, we explore the importance of fair sharing of research software, as well as the research data that it should use. We will see how fairness for data and research software not only significantly enhance scientific output, but also promote sharing within the scientific community. The FAIR principles, first published in 2016, aim to make data findable, accessible, interoperable, and reusable. In 2022, these principles were extended to include specific recommendations for research software. The extensions are known as FAIR for Research Software, or FAIR 4RS. Research software includes software programs, libraries, scripts, tools, and languages developed to support research. However, software used in research, but not created with clear research intent, is different. Examples of these would be a spreadsheet, word processing application, or a general statistical analysis package. This distinction can vary between disciplines. FAIR 4RS provides a set of principles which, when adopted, increase the reusability of research software. These principles include considerations such as adopting software development standards and best practices, developing suitable metadata, documenting the software using a unique identifier for individual software versions and components, providing licensing information for its use, sharing the software and documentation in an appropriate repository, and registering in a suitable registry. When applied to both research data and research software, FAIR principles and best practices can accelerate research progress across the full life cycle by allowing reuse of both the data and tools that transform data into knowledge, maximizing the overall impact of scientific research. Let's watch the FAIR 4RS principles in action. Meet Max Barton, an undergraduate computer science major at a small school with limited resources. Max is passionate about applying artificial intelligence to solve real-world problems and contribute to biomedical research. Dr. Code, Max's computer science professor, specializes in artificial intelligence. She introduces Max to the challenges faced by researchers studying cancer pathology using digital images.
Hi, Dr. Code. I was really inspired by your lecture on AI yesterday. I'm searching for a suitable undergraduate research project. Can you point me to a significant problem that I can solve by applying AI?
Well, if you're interested in biomedical research, I may have some suggestions. Currently, manual analysis of tumor specimens for both human patients and non-human models in cancer research is a labor-intensive process. Researchers initially scan specimen slides for likely regions of interest indicative of abnormal cells. Locating all these regions is not easy, as the process of manually scanning an entire slide is time-consuming, and it may also involve other researchers providing a second opinion for some regions.
Wow, that's so interesting. It seems like an effective AI-driven algorithm could assist the researcher by identifying potential regions of interest over an entire slide in a rapid, automated manner. That way, researchers could focus on classifying irregularities within the likely regions of interest, cutting down the overall time and speeding up the research.
Exactly. However, many of the tools developed have failed in use because the developers did not address realistic artifacts and factors encountered in the lab. To cite just two examples, it's crucial to consider the ability of a tool to work under different imaging resolutions and how to deal with artifacts such as staining variability. Such considerations need adequate handling by any software to succeed in the lab.
Dr. Code, I see there are some challenging hurdles, but I think these can be overcome by applying a suitable set of algorithms. This seems like an impactful software tool, as it could really help accelerate scientific research. I have an algorithm in mind that could work well. Any ideas on how to best get started?
I would suggest first meeting with Dr. Watson, one of our cancer researchers, to get a better sense of the requirements for your research software assist tool. Also, make sure the tool is developed using FAIR 4RS principles, or else users may struggle to understand how to locate, access, and work with it when ready for use.
Max takes Dr. Code's advice and schedules an appointment to meet with Dr. Watson. He describes the software assist tool he is interested in developing and Dr. Code's initial advice.
Hi, Dr. Watson. It's so nice to meet you. Thank you for taking the time to connect.
Of course. I saw your email about the proposed research project, and I think you have a great idea. To start, I would suggest shadowing our research staff in the pathology lab to observe the entire histology process used for analyzing transgenic mouse breast cancer models. As you develop the Image Assist tool, you can bring in our team periodically to evaluate its performance and provide feedback for guiding the development.
Wow, thank you so much.
Collaboration is key. By working with Dr. Watson's team, Max formulates requirements for his research software, ensuring it meets the needs of end users. Max brings what he learned back to Dr. Code.
Hi, Dr. Code. Thank you so much for suggesting I first meet with Dr. Watson. He introduced me to his lab staff, and I was able to observe the entire histology workflow in action, which will guide me in developing the tool. For example, I learned that a variety of stains may be used to visualize cell and tissue features. Slides can be imaged under a range of objective magnifications, and artifacts could be present on the slide images, from dust to cell debris. Here's a more exhaustive list of observations I noted. What do you think?
You've made a fantastic start by visiting Dr. Watson's lab. These observations will be critical in designing and developing your software tool. Once you start to design, develop, and distribute your software tool, don't forget to incorporate the FAIR 4RS principles early. I have a few initial suggestions. Stand up a development environment so that our staff and Dr. Watson's can iteratively collaborate with you on the coding and testing of the tool. Consider using an agile approach, such as Scrum for development of the tool. Scrum has proven to be successful for complex research software projects where requirements are not fully known upfront and require a high level of end-user engagement. It supports rapid tuning of tools to help ensure that these end up with the best suitability and utility for the users. Additionally, perform an initial survey of the status for Image Assist tools developed so far for use in histology. Finally, I would investigate machine vision techniques based on artificial neural networks as a potential solution.
Dr. Code provides a few additional tips to get Max on the right path.
Great, thank you so much. Your advice is extremely helpful. I will be sure to follow FAIR 4RS principles as I develop and release the software. I want to make my tool open, free, universally implementable, well-documented, and with a clear and accessible license. Further, as I continue to develop enhanced versions, I will provide each of these with a unique identifier as recommended.
Max follows Dr. Code's advice, works iteratively with Dr. Watson's team, and successfully develops, publishes, and shares his software tool. The tool gains recognition at the AI in Life Sciences conference. Dr. Tact, an oncologist, acknowledges his tool's impact on her research. She was able to find, download, and successfully use the tool that Max had shared, since he adopted FAIR 4RS principles. For example, since Max clearly specifies the open source license he used, Dr. Tact knew she could reuse the code for her own research. Max is grateful for her acknowledgement and remarks that when he was developing the tool, he used images Dr. Tact shared in the Cancer Imaging Archive, emphasizing the indirect collaboration that can occur as part of the development process. The story of Max Barton and his collaborators highlights the power of creating fair research data and research software. By sharing resources, we can democratize science, enabling all scientists to advance the horizons of knowledge. Join us in embracing FAIR principles. Share your FAIR research data and research software. Together, we can contribute to the scientific enterprise for the better. Should you wish to learn more, detailed information is available in our Research Software Engineering Workbook. Thank you for watching this video.